Another important station transformer. The station transformer mainly, so you can see here, the station transformers are required for general purposes in the station itself, such as station lighting, heating, domestic water supply and battery charging. In station generator itself generating high voltage, that is 11 kV to 33 kV, but different auxiliaries to run. For example, you take the fan or tube light, we require the 230 volts. For 3-phase induction motor, it requires a 400 volts, but generator itself generating high voltage, take the 21 kV, it cannot be run. Then we require to step down to our required voltage, hence we are using station transformers. The station transformers, the step up the high voltage from 21 kV to 400 voltage, it is given to a different equipments. In this one, we are using for the station lighting, illumination purpose, heating, it is necessary for in circuit breakers, and domestic water supply to feed the water to earth pits or some other plants, and the battery charging, it is a very important to charge the battery standby supply. It is a very essential of station transformers. In every station, there is a 2 station transformers. One is standby 1. If any fault occurs in any problem occurs in one station, then immediately shifted to another station transformers. Now, let us go. So, another PTR. So, here you can see PTR, that is a power transformer. The power transformer is the main aim is to step up the voltage up to 400 kV. Due to this one, reduces our transmission losses. So, here you can see, for example, in the outside of the powerhouse, inside there is a generator, it generates the electrical energy. Due to the 21 kV, the size of the conductor you can expect how much, so how diameter. Then due to the ear, the power transformer takes this low voltage, high current and step up to high voltage and low current. Same is connected to bus bar. From the bus bar is passed to different feeders. Now, so another is the feeders. The feeders are mainly feeds the different load centers by using transmission lines. It has also some switchgear and protective equipments. You can see how the feeders connected to substation and how it is transmitted to load center by using transmission lines. These are the few auxiliaries in power station yard. Now, we have seen isolators, what is the functions of isolators, and AB switches and circuit breakers. To perform circuit breakers successfully, we need relays. To function relays successfully, we need the CTPTs, next bus bars, reactors, station transformers and power transformer and feeders. These are the few auxiliaries in outside of powerhouse. Now, you can see here is a clip for you. This is a thermal power station. You can imagine this generator, how big it is. The generator generates low voltage and the voltage is passed to power transformer carried by 3 bus bars. You can see the size of bus bars because voltage is low and current is very high, and these are the 3 bus bars. You can see it. Now, it is carried to power transformer where it step up to required voltage. So, low voltage, here is the high voltage. This high voltage is connected to bus bar, common bus bar, you can see it. Now, this is a common bus. How it is connected? You can see by using ACSR conductors. Now, from these bus bars is fed to the different load centers by using transmission lines. Now, so we have seen different auxiliaries in outside a powerhouse. Now, some of the few auxiliaries in control room. Let us go. What are the powerhouses in control room? So, you can see control panels. The control panel consists of meters, relays and control equipments, etc. Essential meters are placed at the top and remaining are placed at the bottom of panels. Here the control rooms, you can see here figure. Let us assume this is a control room. Here is all relays connected, indicators which relays are tripped on EL or OL, and here is all indicating meters, the voltmeters. It can measure voltage, current, power factor and active power and reactive powers. Here is switches to control. So, each and every part we have to control. It is impossible to a human. Then we will take the assistance of digital computers. By manipulating digital computers, we can control the each and every part in power station. You can see the total circuit. From this one, we can see the load flows, calculations and each and every part of auxiliaries, and we can control from control room. I think you want more details, you can see here is a one clip for you. So, control room, the control room consists of different equipments. This is a nuclear power station control room. Here you can see different meters placed and different equipments connected. Now, here is another meter. So, speed whether low or fast, just synchronizing switch. Now, you can see how they are operated. If any value violated, immediately will inform the concerned operator. You take some actions. Then you can see it. I think you are very familiar about the control room. Now, let us see, so what are the main auxiliaries in control room? Here is a synchronous scope and synchronizing switch. When one generator is to be operated in parallel with other generator, then the synchronous scope indicate when two or more alternators are running in synchronism. The switch used for synchronization is known as synchronizing switch. Synchronous voltmeter, synchronous switch and synchronous scope etc. are mounted on main control panel. Here the synchronous scope is very important. For example, I have the 3 units in powerhouse. 2 are running, now it is connected to the common bus bar grid system. Now load demand is increased, then I want to start it. Then I start it, but I am not connected to the common bus bar. In secondary level, we have seen what are the conditions to be satisfied for parallelization, parallel operation. Its terminal voltage should be same, the phase sequence should be same, and its speed should be, the frequency should be same. These all satisfied, then the synchronous switch shows then you are ready to close the circuit. You can connect the incoming unit to the bus bar. This is connected by using synchronous switch. That purpose we require the one voltmeter, synchronous switch and synchronous scope.